We take a big log and we do what? Break it up into little logs. And then what do? We drop them naturally. All right, so we got 5.1b right here. So when we take a derivative, we always have to remember the what rule? The chain rule. Now, before I even take a derivative of this, we have a natural log of cosine x, absolute value of cosine x. Why does it need the absolute value bars on it? What?
You can't natural log a negative.
You can't natural log a negative. You can't log or natural log a negative number. So that's why the absolute value bars are necessary here. So when we take a derivative, let's do it. So let's take a derivative of this function. How do I notate I'm taking a derivative of it? F prime. Very good. And so this log's not too big, so I don't have to break it up, but we're going to drop it. So my cosine x goes to the bottom. Does anything pop out by the chain rule? Yes. What happens? We get a what out? Negative sign. Now we have negative sine x over cosine x, and that could simplify to negative tangent. All right. Good? All right, let's keep moving. So now we're going to locate the relative extrema of this one. So now we have y equals natural log of the quantity x squared plus 2x plus 3. How do we find relative extremas? I need to find what? Critical numbers. I need to find critical numbers. And how do I find critical numbers? I take a derivative and set it equals 0. So let's do it. How do I notate I'm taking a derivative? dy dx. So, how do I take a derivative of a log? We drop it. But then I can never forget the chain rule, so what pops out? 2x plus 2. Very nice. And what are we going to do to that? We're going to set this equal to 0. Now, when I set this equal to 0, does my denominator really have much effect on it? No. So really I'm setting the numerator equal to 0. So when do I get that? X equals negative 1. That right there is my critical number. However, how do I determine if my critical number is a min or a max? Or relative min or max, I should say. I need a little chart. So now I'm going to go from negative infinity to negative 1 and negative 1 to infinity. All right. So what's left of negative 1? What's on the interval negative 1, 2, or negative infinity, negative 1? Negative 2 sounds great. So when I substitute a negative 2, do I get positive or negative? I get a negative. So dy dx is less than 0. And then I have negative infinity to 0, or negative infinity to infinity, or negative 1 to infinity, dear goodness. Now, 0's on that interval. I'd like to use 0 whenever I can. So when I substitute in 0, I get dy dx is what? Greater than 0. So I'm going a slope of down to a slope of up. So what did I create? A relative minimum. So my relative minimum's at negative 1 comma something. How do I get that other something? I substitute it back into the what? The original. When I substitute it back into the original, I get natural log of what? 2. I get natural log of 2. So now I have a relative minimum at negative 1 comma natural log of 2. Pretty cool? All right, let's keep moving. So now we're on to 5.2a. So now we're going to anti-derive natural log. Or not natural log, but really find the antiderivative of this. So if I have a derivative of natural log is 1 over x, right? We drop it. True? If I go backwards, if I have it in the formation of 1 over x, what would be my antiderivative or my integral of it? Natural log x, right? However, it has to be the absolute value of x. Why does it need the absolute value bars again?
It can never be negative.
It can't be negative underneath. All right, and yes, if it's indefinite, we have to add c. However, what rule can we never forget? The chain rule. So sometimes we need a u substitution going on to see what might get covered or not. All right, let's look at this simple one. I have the integral of 2 over x dx. I could rewrite this as saying the integral, so 2 times the integral of 1 over x dx. You follow me? So on this one, what would be my answer? What is the integral of 1 over x dx? Natural log. So I have 2 natural log of absolute value x and then plus c. Now, sometimes pre-calc properties are happening here. Sometimes you look for this answer choice and it won't be there. What could they do? That's it. Okay, they would use the power property and put it back. So they could actually say this is natural log of x squared plus c. And in that case, would we actually need our absolute value bars? No. However, put them on all of them. All right, it's not going to hurt anything if you put them on all of them. You follow me?
Would go inside the natural bar.
So on this one, I have the integral of 1 over 4x minus 1 dx. Again, what rule do we have to always remember? Chain rule. So, what would be my u on this one? 4x minus 1. So what would be my du? 4 dx. So what needs to be brought out front? A 1/4. So now I have the integral with a 1/4 out front, and then I just have du over u. You see how we did that? So now it's real simple. What is my antiderivative of du over u? Natural log of u, right? So then I end up having 1/4 natural log of absolute value u. But do we want it in terms of u? No, I want it in terms of x. So now we have natural log absolute value 4x minus 1. Add a constant. Pretty good? All right, let's look at this next one. So we're going to find the area of the region bounded by the graph y equals x over x squared plus 1. The x-axis and the line y, x is equal to 3. It's bounded by y equals x over x squared plus 1, the x-axis and the line x equals 3. So this is going to be a definite integral. All right, so let's do it. So what would be my definite integral? What would be my limits on this one? 0 to 3. Of x over x squared plus 1 dx. What would be my u? X squared plus 1. What would be my du? 2x dx. Now, what needs to be brought out front? A 1/2. So a 1/2 gets brought out front, and then I just have an integral of a du over u. However, I personally like to change my limits here. All right? So what would I change my limits to? What would be my new lower limit? 1. I substitute in 0 right there, and so I end up with 1. And then I substitute in 3 right there, and I end up with 10. So now when I anti-differentiate, I end up getting a 1/2, and then what would be my integral?
Natural log of x squared plus 1.
Just natural log of u from 1 to 10. All right, I don't want to put it back in terms of x if I already changed my limits. You following me? You got to do one or the other. I personally think it's easier to do it this way than actually go back on it. All right, once you get rid of your x, don't go back. Okay, all right. True story, true story. All right, so here we go. So now we're using first fundamental. So now we have 1/2, and then we end up having natural log of 10, and then what? Minus natural log of 1. Now, what is natural log of 1? 0. So that goes away. So I end up having 1/2 natural log of 10. Pretty good? How else could they write that? They could say natural log of square root 10. All right? So don't always think that that one answer that you got when you did your problem is going to be the only answer that it could be written as. Are you following me? So sometimes they use that algebra 2 or pre-calc going on. All right? And that's what it looks like. How about that? All right, let's move. So let's look at these. So now I have the integral of 3x squared plus 1 over x cubed plus x. Elijah, what's my u? Good. So now I have x cubed plus x. That's my u. So what's my du?
3x squared plus, plus 1.
Dx. All right. Did it cover?
Yes.
Perfectly. It covered perfectly. So now we end up having the integral of du over u. I agree. How convenient. I agree. All right. So then, what's my antiderivative? Natural log of absolute value x cubed plus x plus c. All right. All right, let's look at b. So now I have the integral of secant squared over tangent x dx. All right, again, we need to pick our right u. So what is my correct u here?
X squared plus 2x.
Tangent x.
Oh, wrong.
So what's my du?
Secant squared.
Secant squared. Did it cover?
Yep.
Perfectly. It covered perfectly. Can we go straight there? What's my antiderivative? Natural log of absolute value tangent x plus c. Now, on those last two, were the absolute values needed?
Yeah.
Absolutely, they were. All right? You had to have them. Okay? So you might as well put them on all of them because sometimes students actually just use parentheses and sometimes it's actually needed. Actually, a lot of times it's needed. You follow me? All right. So let's look at this next one. Now I have x plus 1 over x squared plus 2x, the integral of it. All right, TJ, help me out. What's going to be my u?
I don't know.
Yeah, you do. What's my u?
X squared plus 2x.
Good. All right. So what's my du?
2x plus 2.
2x plus 2 dx. Did it cover?
Yeah, not perfect.
Kind of, sort of.
Yeah.
Kind of, sort of. But what would I actually do to my du? I'd factor out a 2. And so I'd manipulate it a little bit. So if I factor out a 2, then I'm left with what?
X plus 1.
X plus 1 dx. So did it cover?
Yes.
Yes, but did it cover perfectly? No. So what needs to be brought out front? A 1/2. And so now I have 1/2 the integral du over u. All right. So what's my antiderivative? 1/2 natural log of
X plus 1.
x squared plus 2x plus c. All right. Again, how might they rewrite that one?
Square root.
The natural log of the square root one. All right. So anyway, that could be how they do it. All right, let's look at D. So now I have 1 over 3x plus 2 dx. What would be my u? 3x plus 2. So what's my du? 3 dx. Did it cover? Dx has got covered, so that's good. It's just a constant multiple that's messed up. So what do we need to bring out front? A 1/3. Can we go straight there? 1/3 what? Natural log of 3x plus 2 plus c. All right. On all of these problems, I'm not going to worry about my trig function on B. But on D and C and A, what was my difference of powers from my denominator to my numerator? What was my difference of power? 1, right? 1 bigger on the bottom. How about this one? 1 bigger on the bottom. How about this one? 1 bigger on the bottom. Not. So let's look at this one. So this one, does it have a difference of power of 1? No. So daggone it. I have an x squared plus x plus 1 on top, and I have an x squared plus 1 on the bottom. Here's the trick. If you have the same or the higher power up top, you need to log divide. Long divide. All right? Wow, no giggles on this. That's tough. I thought that was good. I thought that was good. All right. So if you have the higher power that's the same or on the top, what do? Log divide. All right. So let's go back to algebra days. Here we go.
What? Wow.
We log divide. We got a long divide. All right. So now I have x squared plus 1. I'm going to divide it into x squared plus x plus 1. I love long dividing. I love these. Long dividing is so much fun. So here we go. How do I get from x squared to x squared? 1. So I put a 1 there. Then we multiply 1 times x squared. We get x squared. And then I multiply 1 by 1, which is 1. Then what would I highly suggest you do?
Drop the x.
Choom, choom. We distribute the negative. And then we do what? Add straight down. So what happens to my x squareds? They cancel. My x drops, because Snoop Dogg said. And then what happens to my 1s? They cancel as well. So I have a remainder of an x. So now I end up having 1 plus x over x squared plus 1. And so the integral of what we originally started with is the same thing as saying that. I just manipulated the way it looks. Guys, let's catch up. All right. Oh, so now I've manipulated it. So now we just take an integral of it. So what's the integral of x? Or dear goodness, what's the integral of 1? X. Very good. And then plus, ooh, looky here now. I have a difference of power of 1 here. So guess what? What's my u? What's my du? 2x dx. Can we go straight there? What needs to be brought out front? A 1/2. And then I have what? Natural log of absolute value plus c. All right. Now, technically, did that one need the absolute value? No. However, just put it. All right, just put it on all of them. You follow me? All right. All right, I want you to these doubts, and then I'm going to do another long division one with you. This is number 18. What do we notice? Higher powers on top. So what does that trigger? We have to do what? We have to long divide. All right. So I have x plus 5, and then I end up having x cubed, and then what do I need? Plus 0x squared. And then minus 6x, and then minus 20. Yeah, Alex said ox. Yeah, he did. All right. He was actually paying attention. I was so happy for him. This is still recording, right, Alex? Yeah. All right. So how do we get from x to x cubed? X squared. So I get an x squared right there. So now I have x cubed and then plus 5x squared. What would I highly recommend? Pew, pew. So then I drop it. So now I end up with negative 5x squared. And then we drop that like it's hot. How do I get from x to negative 5x squared? Negative 5x. And so then we multiply by negative 5x. And now I have a negative 5x squared. And then what? Minus 25x. And then what would I highly recommend? Pew, pew. And then my x squareds cancel. So that's cool. So then how many x's do I have? 19. And then I drop it like it's hot. And then how do I go from x to 19x? 19. Oh my goodness, we're going to get a big number. And then I need to multiply. So now I have 19x and then plus 195. I like that. All right. And then what? Pew, pew. And then we add straight down and we end up with negative 215, right? All right. So that negative 215 is my what? My remainder. So now I've just changed my integral just the way it looks to x squared minus 5x plus 19 and then minus, I'm going to say plus negative, 215 over x plus 5 dx. All right. These two things are the samesies. All right. So now can I integrate that next one? Yes, I sure can. So what's my antiderivative of x squared? X cubed over 3. And then, what's my antiderivative of 5x?
Like you believe.
I believed Evan. This is 95.
Good job, Josiah. Detective Josiah.
This is 115. All right, fantastic. All right, so then what is my antiderivative? Negative 5 halves x squared, and then plus 19x, and then what would this antiderivative be now?
-115 natural log absolute value of x plus 5.
There it is. All right. And then we can actually do that integral. Good, good?